So today we are talking about that hypothetical caffeine experiment we were going to do yesterday. So we have some results from the caffeine experiment. The first graph shows the change in the pulse rate when the total amount of soda drank was kept constant. So like everyone was given like 2 milliliters of soda kind of thing. And they either have one that has caffeine or one that doesn't have caffeine. In the second graph, it's where they're allowed to choose how much soda they want to drink. So the first thing we want to do here is decide what evidence there is that one of the drinks increases the pulse rate more than the other. And the way we're going to do this is we're going to find the average of the change for the caffeine and no caffeine for the soda constant, and then the average for the caffeine and no caffeine for letting the amount of soda vary, and then compare the two means. So what I want you guys to spend time doing right now is finding the mean for the caffeine, no caffeine for the soda constant, mean for caffeine, and no caffeine for letting the soda vary. Okay, so what did you guys get for the average for caffeine with constant?
6.
Okay. And no caffeine constant?
44.
I should use bullets. Okay. And then caffeine not constant? And no caffeine not constant. What was that? I wanted 0.8. What am I writing? Okay. So now that I have my two means for each situation, I want to find the mean, the change in means for them. So the change in mean for caffeine. I hate how much these words rhyme. They're so hard to say. So when the caffeine was constant, it was 6. When it wasn't constant, it was 5.6. So the change is negative 0.4 because I'm going from constant to not constant. I'm going to write that up above too. Okay. And then the change in mean for no caffeine. So based on what we have, what can we, oops, I did not mean to hit my paper. What can we say based on this evidence? Do you think 0.4 in a pulse rate is a high number either direction? Okay. So I could say that there is no effectiveness in the two drinks. We just got differences due to random assignment. God, differences, not different. Alternatively, these numbers are different for each mean, so I could say there is a difference.
So the pen tip didn't come out right, so pushing it to the side, like straight. But eventually,
The data isn't, like, depending on how I want to interpret it. So, like, 0.4 in general is not a very large change in pulse rate. So I could say there's no difference. But if I'm comparing the two numbers to each other, one has a positive change and one has a negative change. So I could say that there is a difference. So, okay. So how can I decide if this evidence is convincing? Guys. Like how?
Like convincing that it doesn't work?
Well, either way, because right now I can have two explanations, and if I argue right, you guys will believe me for either one, right? Because the first one where I say there's no difference because 0.4 isn't a big change at all, you guys will believe me. But if I say there is a difference because one's got a positive change and the other's has got a negative change, you guys would also believe me if that was the first thing I told you, right? So how can we decide if the evidence is convincing? Huh? So I could try again, but that's not what I'm looking for here. So okay, so this one I would want to compare the observed difference in means with what could happen by chance alone. So I probably would want to compare to like a group of people who didn't drink anything at all to see if the, yeah. In this situation, because the numbers are so close together, I would want to have a third group just to not drink anything at all. Because who's to say that it's, yeah, this isn't a question on here. Who's to say it's not the sugar from the soda that's making your pulse rate change?
Oh, it's like who drank, who didn't drink caffeine because there's no caffeine soda.
Yeah, because like root beer still has a ton of sugar in it.
No caffeine. So it's like, oh, I understand.
There we go. So my last definition is statistically significant. This is when the observed results are too unusual to be explained by chance alone. So if, for example, if my change in the one where they had caffeine was like 15 for the change in pulse rate, that would probably be statistically significant because that's a really large jump, right? So, well, I mean, would that surprise you with caffeine? Like, imagine drinking a Red Bull.
4 Red Bulls.
Okay. So basically, what I want to say is statistically significant results are the same thing as convincing evidence. Remember, this means congruent. So the same thing as